Alright guys, so we're going to do a review of the U-Try. Hopefully this was pretty productive for you. So we're starting here. We're not starting down in the video notes. I want to do a review of the U-Try first, then we're going to go into the video notes. Here's what we know. We know that a circular swimming pool can hold 1,125 pi cubic feet of water. If the water is 5 feet deep, at all parts of the pool, what is the diameter of the pool? Well, let's label what we know. So the first thing we're going to do, we see over here in these steps, is we're going to draw and label the picture. So already drawn for us, which is nice, but let's label some stuff. I know that the volume, and I usually write this inside the shape, but you can feel free to do what you want. The volume is equal to 1,125 pi cubic feet. And then it says the water is 5 feet deep at all parts of the pool. So I'm going to assume that means that the height of this thing is 5 feet. And let's keep in mind we're working in feet. It's cubic feet and this is feet. So now I've drawn and labeled the picture. It wants to know the diameter of the pool. So I'm actually going to underline what it's asking for, because I don't want to pull a Martinez and solve for the wrong thing. So what is the diameter of the pool? Okay. I've drawn, labeled the picture, and made sure I know what I'm talking about. I'm going to check that off. Now, next step. Every time, and we've put this checklist on all of these problems for you so that you can go through this. If you're not doing these, you're going to end up getting some of these wrong. But if you follow these steps, they're actually very simple to follow. So I'm going to leave the things I know in blue and the things I don't know in red. So I'm going to start with this. The general formula is volume, and this is a cylinder. It's a kind of goofy looking one, but it's a cylinder. The volume is equal to, well, volume of a cylinder is pi times the radius. Times the radius squared. I'm getting ahead of myself. Times the radius squared times the height. So I have pi times the, I wrote cubed again. Oh my gosh. Pi times the radius squared times the height. There we go. I can do this. So now that I've written the formula, I'm going to go in and I'm going to do step 3, which is substitute in known variables. Known variables. So let's sub in what I know. I know that the volume is 1,125 pi. And that's equal to, well, pi is always pi, so I'm going to leave that as is. I don't know what the radius is. I don't have any of that information, so I'm going to leave a space. And then I'm going to say, well, the height I know is 5. Now let's do in red, radius squared. So now that I've done all of that, I'm going to solve by showing work. I'm going to solve for these values. Now, hopefully you remember in my class earlier in the week, we realized one of the easiest things we can do right away is we conveniently have pi on both sides of this equation. So if I have pi on both sides of this equation, if I have pi on both sides of this equation, I'm just going to divide both sides by pi to start. Because again, my goal here is to solve for this missing value, which is r, which we've left in red, because that's the one thing I don't know. Now, when I divide by pi, those are gone, and I'm left with 100 or 1,125 equals 5 times r squared. And I just switched these because you can do that with multiplication. I didn't have to, but I could. Now what I'm going to do is I'm going to isolate r by dividing by 5. By dividing both sides by 5, because over here I have 5 times r. Now we're going to go down, we're going to say, okay, I need my calculator. bring this over here where I can work with it. And I say, okay, 1,125 divided by 5 gives me 225. So now I know that 225 is equal to r squared. But I don't want r squared, I want r. So I'm going to square root both sides. Hopefully you remember that the square root of 225 is 15. So I know that 15 is equal to r. And then part of me kind of just wants to say I'm done, but I'm not. I need not r, I want the diameter of the pool. And I know that if the radius is 15, then the diameter is 2 of those, which means that the diameter is equal to 30, because I have 2 radiuses, both of which are 15, 30, and then no negative numbers, feet. So the diameter of this pool is 30 feet. Now, hopefully you were able to see how that worked out. I'm going to leave these notes on here so that we can reference back to them. Once again, I did that, and then finally I circled my final answer, and I put in appropriate units for full credit. Now, let's come down here and actually do the video notes. So there's a bunch of these. We're going to set these up and go pretty quickly. Hopefully the repetition will be helpful. Now, an NHL hockey puck has a volume of 2.25 pi cubic inches. So I'm going to label this 2.25 pi, and that's the volume, and a height of 1. So a height of 1. I've drawn and labeled my picture. Now I'm going to say volume equals pi times the radius squared times the height. I actually missed a step here. Hopefully you caught that. I need to solve for the radius. I want to know what I'm solving for, which is the radius. So I've done this. Now I'm going to input, I wrote my formula, I'm going to substitute in known values. So I say 2.25 pi is equal to pi times the radius squared times height. The height is 1. Radius squared we'll do in red again, just so we can keep some consistency. And now, again, my first step, just as I did up here, let's get rid of pi, because it's on both sides. So I say divide by pi, divide by pi. Pi is now gone. I say 2.25 equals 1 times r squared. Well, now I can divide by 1, which doesn't really help me, but it at least isolates some things, and I get 2.25 equals r squared. Equals r squared. Then I'm going to go back to my calculator, r squared. I know that this is 1.5, but I just want to check and show you also. So 2.25 square rooted, I can use this symbol to square root. Again, I don't want r squared, I just want r. So I'm going to square root both sides. And in the process of square rooting, I find out that the radius is equal to 1.5. So I've solved. Now I need to circle my final answer and make sure to use appropriate units. In this case, we're talking about inches, 1.5 inches. All right, let's go down to number 4 here. The circumference of a cone. Well, now we're dealing with something a little different. The circumference of a cone is 12 pi yards, and the volume is 12 pi yards cubed. What is the height of the cone? Well, now we need to do something slightly different. We're going to start off by drawing and labeling the picture. So I draw this, and I want to know the height of this. I don't know the height, but I know that there's a way to find it. Now, I'm going to start off by writing the formula. I'm going to start off by writing the formula of what I know. Well, I know that the volume of a cone is equal to pi times the radius squared times the height, all of which is divided by 3. Now I need to substitute in known values. But that's kind of tough initially because I know the circumference of the cone. So let's go back here and look, what is circumference? Well, circumference is pi times the diameter, or pi times 2 times the radius. So let's say circumference is pi times the diameter. Well, if the circumference is 12 pi, then the diameter is logically 12. So the diameter is 12. If the diameter is 12, hopefully you've realized that the radius is half of that. So the radius is 6. Now I have some values I can substitute in. So if the radius is 6, I'm going to say, okay, volume equals pi times 6 squared times the height, all divided by 3. That's kind of tough to see, so I'm going to move this just so you can see what we're really dealing with here. So now that we have this, there's one piece I forgot, I'm sorry, and that is the volume. The volume is 12 pi. So first thing I'm going to do is I'm dividing by 3 over here, so I'm going to multiply both sides by 3 times 3. That just gives me 36 pi. Let me write this a little lower so it's easier to see. Just gives me 36 pi equals, well, that's gone now, pi 6 squared times the height. Well, hopefully now you see that we're going to do the exact same thing we did before, where we're just going to divide by pi. And now we have 36 equals 6 squared times h. Well, now let's carry this through. 6 squared is 6 times 6, so I get 36 equals 6 times 6 is 36 times h. And then I'm going to divide both sides by 36 so that I can move this one away from the h. And I end up finding out that the height is equal to 1. The only quick shift I need to do, I substituted in known values. I need to circle my final answer and label. So it's not just 1 is h, it is 1 yard is equal to the height. 1 yard is equal to the height. Now the only tough part of this was the circumference, because the rest of it was exactly the same. And the easiest thing to remember with circumference is equal to the diameter times pi. So when they give you something like this, you know that that is the diameter. And if we know the diameter, then we know the radius. And finally, we're going to do this last one. I'm going to start off by drawing and labeling a picture. The height of a coffee can is 6 inches and the volume is 54 pi inches cubed. What is the radius? What is the diameter? Well, these are what I want to solve, specifically for radius and then diameter, but that's not tough. I'm going to draw and label a picture. Here is my badly drawn coffee can. And I know a couple things. First off, the height is 6 inches. The volume is 54 pi inches. And I need to solve for the radius. So I come up here and I do my second step, write the formula. This is a cylinder, so volume is equal to pi times the radius squared times the height. And then I come down and I say, well, the volume is 54 pi equals pi. The height is 6, and the radius squared is, well, radius squared right now we don't know. So now I say, okay, let's start off with the same thing we do every time. Divide this by pi. And I get 54 is equal to 6 times the radius squared. Well, now hopefully you see I'm going to divide both sides by 6. And I get 9 is equal to r squared. And I don't want r squared, I want the square root of r squared, which is just r, which tells me that the radius is 3 inches, and therefore the diameter is 6 inches, because again, let me do the radius in red so you can see this. The radius is halfway across the top of this can, or the bottom of this can, it doesn't really matter. That's 3. And if I add a second radius, I create the diameter, which is in green here, which would be 2 of these 3's, which gives me actually 6. So the diameter is 6. Hopefully that was helpful. You're going to transition now into the partner practice. Again, use all of these as references to go back and check. Hopefully that was informative. If you do have questions, please raise your hand.